Hello everyone, and welcome to the second half of our 7.3 video on rational exponents and the radicals that go along with them. After watching this video, you should be able to evaluate a rational exponent with the calculator and also solve a simple equation that involves a variable as the exponent, which we call an exponential equation. So if you have something like 2 to the x equals 8 squared, you should be able to figure out that x equals 6. And that's true, and I'll explain a little later as to how we figure that out. So, first part, evaluating with the calculator. If we have something funky like the cubed root of 64 squared, okay, and we want to figure out how to what that comes out to as a single number, the first thing we want to do is use exponential notation to easily type this into the calculator. So the first thing we want to do is take that third root of 64 squared and use the rule we learned from the previous video to make that into 64 to the 2/3 power. And again, the power stays up top in the numerator, and the index, this number here in the front, that becomes the denominator of our exponential, or excuse me, our rational exponent. So once we have it there, we want to type it in the calculator just like this. So 64 caret parentheses 2 divided by 3 close parentheses, and then once we press enter, we'll get the 16. So again, exactly as you see it here, 64 caret, that gets us up into the exponent. Then we have to put this fraction in parentheses. I've been saying for a long time, put all the fractions in parentheses, and here is no different. And if you follow that same rule, you'll figure out quite quickly that our answer here is 16. Now, if you can take a moment, pause the video, pull out a calculator, and try and evaluate this expression. Now, if everything went to plan, you typed in 8 to the 2/3 power, you used your caret in your parentheses like we talked about in the previous slide, and you found out that this equals 4. Okay, very straightforward. We're just using the calculator. We'll practice this some more in the homework. Next, we're going to get to the part where we're actually solving simple exponential equations. Now, simple is relative. Exponential equations can get very difficult to solve, and we'll talk about some of those in later sections, and even more so when you guys get to Algebra 2. But for right now, we're dealing with the simple case. And the simple fact is that if the bases are the same, then the exponents are the same. So here we have an exponential equation. 2 to the x equals 2 to the 5th. What makes it an exponential equation is that we have the variable as the exponent or as part of the exponent. You'll see what I mean about part of the exponent later. But basically, if this is 2 and this is 2 for the base on each of these, well then this exponent has to equal that exponent, otherwise it won't work. Okay, we're not going to worry about proving that right now, but that's the nuts and bolts of it. So once we verify that this base and that base are the same, then we know that this exponent and that exponent are the same, and we figure out that x must also equal 5. Now, when we talk about simple exponential equations, this is about as simple as they get. The bases are already the same, the variable is by itself, so you just set the variable equal to the other exponent, all is good. But as you can guess, it's going to get a little trickier. For example, 3 to the x plus 6 equals 3 to the 9th power. Now you'll see problems like this as kind of our starter version of these types of problems, and they're going to go as you expect. We have the same base, a base of 3 and a base of 3, so since the bases are the same, that means the exponents have to be the same, so I have to set the exponents equal to each other. X plus 6 equals 9, x plus 6 equals 9. Then from there, it's pretty straightforward to figure out that x is going to equal 3. Now, because I have faith in you guys, I'm not going to do the whole subtracting 6 from both sides to figure that out, but that's what you'd have to do for a more complicated equation if it was necessary. For example, you might get something like this. Go ahead and pause the video, try this one out, and then compare your answer to what I get. Hopefully, as you were doing that, you noticed we again have the same base, 7 and 7, which means the exponents are also equal to each other. So x minus 3 equals 4x, just like that. And then from there, it's just a matter of solving the equation like we've talked about before. You'll subtract the x from both sides, get negative 3 equals 3x, divide both sides by 3, and you should end up with x equals negative 1. Hopefully you didn't have any problems with that, but if you did, pause, ask some questions, Check with your partners if you need to. Write them down and bring them to me next time we see each other. Now, another type of these equations you will see is the case where the bases are not the same. So here you see we have a base of 2 and a base of 8. Now these ones are tricky because you really got to kind of know your powers, or at least be able to check them. We look at a base of 2, and that's obviously the simple one, but then we have this base of 8. But if you're good with your powers, you'll probably know off the top of your head that 8 is really 2 to the third power. Now, if you don't know that, you're going to have to do some guess and check, because you know that the base is 2, and we need 8 to have a base of 2, so you'll have to pull your calculator out. Okay, what's 2 squared? That's 4. Okay, what's 2 to the third? Oh, that's 8. Okay, there it is. But ultimately what we're doing is we're taking 8 and replacing it with the base of 2 to whatever power is necessary to make it so that it's a base of 2. Now, I'll give you a hint. I'm not going to give you anything that's super complicated where you can't easily find the like bases to be like this. But this is a simpler case, and it's a good one to warm you up for some of the stuff that you'll see later. So once we have 2 to the x equals 2 to the 3 squared, well, now we have to simplify this. And if you were wondering why we always had those examples with the numbers, here's a point where that's useful to us, because 2 to the third to the second power, this goes back to our power of the power rule, which means we're going to have to, pause for effect, multiply the exponents, and that should get us 2x to this 2 to the x power equals 2 to the 6th power. Bases are the same, which means the exponents have to be the same, so x equals 6. Now, as usual, we'll start off with a simple problem, but we'll try something a little more difficult, like, say, this. Don't freak out. Try and find the like bases. See if you can solve this one. Pause the video, see what you come up with, and then compare what you did come up with what I come up with. Okay, so again, the first thing we need to do is get these bases to be the same. Now, this is our smaller one. It's got the variable, so we're probably going to want to make this match that. So 12 to what power equals 40 or 144? Answer should come right to you. It's 12 to the second power. So this becomes 12 to the 2x plus 3 power equals 12 to the second power, 12 squared. All right, now that we've got our like bases, we need our like exponents. Set our exponents equal to each other. 2x plus 3 equals 2. Once we get to this, it should be kind of a breath of fresh air, a sigh of relief. Oh, okay, I can do this. I'm going to subtract 3 from both sides, divide both sides by 2. Yes, you're going to get a fraction, but it's okay. X does equal -1. Don't freak out. Like I said, these problems can be a little tricky, and they're designed to be so. But the key thing that I want you to remember is get the bases to be the same. That's going to wrap up this video for now. Watch the quick overview, and then take a crack at the homework.